So in this lesson, we're going to be talking about square root graphs. A square root graph looks like the following: y equals the square root of x. Now, what do we know about square roots? We know that you can't square root a negative number. So therefore, we have to say that x is equal to or greater than 0. So I'm going to write for x is greater than or equal to 0. Let's now see what this looks like. So we're going to graph it, and we're going to do so by first filling out our table of values. So we're going to begin by subbing in 0 into my x spot. So the square root of 0 is 0. So I'm going to pop that there and put a 1, 0 here. Let's now move on to x equals 1. What happens when I let x equal 1? I get 1 out. So I'm going to put 1 here and come up here and put that in. I'm going to skip 2 and 3 and go straight to 4. What is the square root of 4? It is 2. So I'm going to put 2 in my y spot and graph that. Hopefully you see what I'm doing. I'm going to all my squared numbers. The square root of 9 is 3. So I'm going to put 3 here. I'm then going to go to my next, which is 16. The square root of 16 is 4. So I'm going to put a 4 here and plot it on. I'm then going to graph it like so. And I have just drawn y equals the square root of x. And as you can see, all my x's are equal to or greater than 0. So this is really the parent rule. I'm going to be referring to it as the parent rule, and we're now going to apply some transformations to it. So let's now do that in our next example. So as you can see, I now have y equals x plus 3. So it's going to be a little different. Let's begin by putting down my parent equation of what we just did. So what I just did in the last example was show you what y equals the square root of x looks like. So now we've got this plus 3 at the end. How does that change things? Well, let's switch up our color and go y equals the square root of x plus 3. Again, we know that we can't square root a negative number. So we're going to have to say whatever is inside this square root is going to have to be equal to or greater than 0. So I'm going to say for x plus 3 is greater than or equal to 0. But as you know, we normally just have x by itself here on the left-hand side. So I'm going to minus 3 to both sides and going to be left with x is greater than or equal to negative 3. And this now makes sense, because if I was to put negative 3 into this spot, negative 3 plus 3 is going to be 0. The square root of 0 is 0. That's fine. Where things start to break down is where I have a number less than negative 3. For instance, if I was to have negative 4 here, I would have negative 4 plus 3, which is negative 1. You can't square root negative numbers. So x is going to be greater than negative 3. So that means my graph is going to start here at negative 3, 0. And I'm going to draw that in like so. So as you can see, what's happened by plussing 3 here, I have shifted my parent graph 3 to the left, or 3 to the negative direction. And this is where people get confused sometimes, because this plus is telling me to shift it 3 in the negative direction. Another thing we have to be careful of is making sure that I tell you where my y-intercept is. So to find y-int, let x equal 0. So we'll get here, I'm going to go y equals the square root of 0 plus 3. I'm going to get y equals the square root of 3, which means here, this is going to be 0, the square root of 3. Perfect. The main takeaway is that whatever I'm doing inside the bracket, inside the square root here, if I'm plussing, I'm going to shift it in the negative direction. And if I'm minusing, that's going to mean I'm shifting it in the positive direction. And that's what we're going to see next. So let's do that now. X minus 2. So we know that because there's a minus 2 here, that means I'm shifting 2 positively. So it's going to look like this. So I'm going to begin at 2, 0. So again, don't get stuck by this negative. This negative is telling us we're going 2 in the positive direction. And again, I could write out y equals the square root of x minus 2 for x minus 2 is greater than or equal to 0. And you have to put this into this form. So x is greater or equal to 2. Perfect. Let's now keep on chugging along. All right, so as you can see here, we're no longer adding or subtracting within the square root. We're now doing it outside of it. So how is this going to change things? So what I'm going to do is I'm going to write out this formula. So y equals the square root of x plus 5. And we know that this is going to be for where x is greater or equal to 0. That hasn't changed, because if I was to put a negative number in here, it's not going to work. It has to be greater or equal to 0. But how does this plus 5 alter things? I'm just going to tell you straight away, this plus 5 is going to shift it 5 up. So my graph is going to look like this. 0, 5. So again, this one is more straightforward than when it's inside the square root. If it's plus, it goes up. If it's negative, it goes down. And just to really flesh this out a bit more, let me compare this to our parent function. So if you remember, I'm talking about our parent as this one, and then our new one, our transformed, is this. Let's see what happens when I put 0 into it. So if I let x equal 0 here, I'm going to get the square root of 0, and I'm going to get 0 out. So that means my starting point is going to be there, and it's going to go up. But if I was to put 0 into this one, I would have 0, the square root, plus 5. The square root of 0 is 0, plus 5 is going to equal to 5. So when I put 0 in, I get 5 out. So 0, 5 is going to be my starting place. And that's right here. So this is what happens when we plus 5 to our parent function. We're going to shift it 5 up. Whoops. That one is just the parent function. All right, let's keep going to our next one. So immediately, just by looking at this, we should be able to say, all right, y equals the square root of x minus 4. And we can say this exists for x is greater than or equal to 0. This negative 4 is going to shift it 4 down. So it's going to look like this. And I can say this is 0, negative 4. Also very important that you tell me what the x-intercept is. To find x-int, what do? I let y equal 0. So 0 equals the square root of x minus 4. Put 4 on this side, square root of x, square both sides, I'm going to get 16 equals x. So that means here, this obviously is not to scale, it's going to be 16, 0. So my starting point is going to be 0, negative 4, and my x-intercept is going to be 16, 0. Perfect. So that's transforming left to right and up and down. Let's see now what happens when I start introducing negative numbers. What happens now when I have a negative number? Well, let me begin by putting in my parent function again. My parent function was this. Y equals the square root of x. So now what's going to happen when I have negative x? The first thing you should be thinking is, well, I thought you couldn't have negative x. I didn't think you could square root a number by a negative. So how on earth is this going to work? Because you'd be right. You can't square root a number by negative. So I'm going to still write 4 inside my brackets, negative x, has to be greater than or equal to 0. Now, as you remember, you can't have x with anything else. It has to be x by itself when you're defining where it exists. So I'm going to have to get rid of this negative. How am I going to do that? I'm going to do it by dividing both sides by negative 1. So that's going to get rid of my negative on this side, so I'm going to be left with x. Now, whenever I divide across by a negative, that's going to change the direction of my inequality, and 0 divided by negative 1 is still 0. So therefore, this is what we're working with. So it's going to be 4 equals the square root of negative x for x is less than or equal to 0. In other words, what it's saying is that all my x values have to be negative. And that makes perfect sense because let's put in a negative number in there. Let's put in negative 4. If I put negative 4 in there, negative times negative is a positive. So I'm going to be left with 4. So I've got rid of that negative in the inside. And of course, I'm going to be left with 2. So basically what this thing is doing is telling me that x exists for everything less than or equal to 0. So it's literally just going to go in the opposite direction now. So it's still going to start at the origin. It's just reflected in the y-axis. So that happens when my negative is inside the square root. Let's now keep going and see what happens when my negative is outside the square root. Whoopsie daisy. All right, so as you can see now, let me put in my parent function just to begin with. Y equals the square root of x. All right, so now I have my negative on the outside. How is this going to change things? Well, I'm going to write out my function, negative the square root of x, 4, and again, x, whatever is inside my square root, has to be greater than or equal to 0. So that isn't going to change. Nothing is affected by this negative on the outside in terms of what my x can be. But what does this negative on the outside affect? Well, let me sub it a number and see what happens. Let me again put 4 into my x spot. So x, 4. The square root of 4 is 2, so I'm going to be left with negative 2. So in the past, when I was dealing with my positive function, when I put 4 in, I got 2 out. But now when I put 4 in, I'm getting negative 2 out. I'm getting here. So what's happened is that I've reflected the point across my x-axis. So it's going to end up looking like this. This will be y equals negative on the outside, square root of x. So let me get rid of this as not to confuse anyone. So having this x on the outside here, that is causing a reflection across my x-axis. It's going underneath now. Let's now do some transformations. So again, we should be able to look at this and go, all right, I have a square root within my, I have a negative within my square root. So that means I'm going to reflect it across my y-axis. And then I have plus 9. So it's going to plus 9 up here. It's going to move it vertically up 9 spaces. I'm going to get rid of that. So here will be 0, 9. Perfect. We did that pretty successfully. And again, I would have to define it. So y is negative x plus 9, where x is less than or equal to 0. Perfect. Let us keep on going to this one. We can go about this a few different ways. So I have y equals 2 minus the square root of x. And again, this is going to be for where x is greater than or equal to 0. Immediately I see this negative and I know I'm flipping it across my x-axis. And then I've got this plus 2, which means I'm going to shift it 2 up. So it's going to look like this. I'm going to rub out what I did originally. And this point is going to be 0, 2. And then I have this x-intercept. Oops, to find x int, let y equal 0. 0 equals 2 minus the square root of x. I'm going to move this over to that side. I'm going to divide both sides by negative. And then let me come up here. I'm going to square both sides. So I'm going to be left with 4 equals x. So this point here will be 4, 0. Perfect. So hopefully you understand how to transform your parent y equals square root of x, your parent square root graph, up, down, sidewards, and reflections. And here is just a little table to help you remember how to do things. So if for my c is going to shift it left or right or left. If it's negative, it's going to the right. If it's positive, it's going to the left. And that's where people might get a little stuck. For my d, it's far simpler. For d, up is positive, down is negative. All makes sense in the world. Just make sure you don't get stuck with the left and right for the c value. If my a is a negative, it's going to flip it over the x-axis. And if my b, with inside the square root, is negative, it's going to flip it over my y-axis. Hopefully that made sense. There is some else stuff about shrinking and stretching and dilating and all that. Don't worry too much about that. That's we're going to focus on that a bit later. But for now, hopefully how to transform a square root function makes sense. Hope this was helpful.